All right, so we've made a ton of headway in this unit, which is talking all about object-oriented programming, which is when we have some instance of thing that's an object, and we've talked all about the different options that come along with that. So we started with the four principles, which is just why are we doing this? So we can have like a concrete item. So like my phone is an item. And there's different properties that my phone has of like what's the model, how much storage does it have, what is the list of installed apps, things like that. How do I know when I have touched the screen of my phone? Those are things and methods that I can use if I have a phone object in code. And so we talked about different kinds of methods. So like the toString and like what's a static method, etc. So we talked about those kind of basic building blocks. And then we talked about inheritance, how we can link these classes together. And so that where we had something like a shape and a circle. Or a triangle. And then from a triangle, we could go to an isosceles triangle, an equilateral triangle, and so on. So we can have this family tree, and then we can also build it in code. So we're going to talk about parameterization / generics today. We won't talk about functors, function objects, but these are included in the readings, I believe. Okay, so homework 4 is also assigned for the inheritance unit. Let's talk about that really quick. All right, so homework 4 is I give you, here are these classes, or I tell you, here's what the classes are, and then I give you some specifications. So here's what bank is, here's what bank stores, here's what bank does. And this is similar for account, interest-bearing account, interest checking, platinum checking, non-interest checking. And so this is like, if you've got a bank has different kinds of accounts that it can open for you. So you can have a checking account that gets a little bit of interest or a lot of interest, like the platinum checking account. Or maybe if you're, I don't know, like a student, then they give you an account that doesn't get interest, right? So something like that. And so your job is to just implement these classes and then create a driver file that tests and produces output something like this. And so the exact numbers don't need to match, but the general format and the functionality should be identical. And then a UML diagram. So it's fairly straightforward, just practice in implementing something using inheritance according to some specifications. So that's homework 4. But now we're in this sort of subunit 3 where we'll look at lab, what I'm calling 5A today. And so let's briefly talk about, remember when we've talked about arrays and we've talked about lists, right? Where both we kind of represent as this long rectangle divided into boxes. And so let's say this is going to be a list full of triangles. So in order to define that, so far we've needed to say this is a list, and we put an angle bracket that there are triangles in this list, right? And so one of the questions that we always have when we talk about lists is there's angle brackets What are those? Why am I doing this? Why is it not like arrays? Now we're going to talk about that. So we've seen many examples of reference types so far. We've made a lot ourselves. So this includes, we made a smart house. We can, for the lab 4, we had books, we had authors, we had libraries. We made a combo lock, person, student, employee, circle, rectangle, square, so on and so forth. All of those types store different types of data. Some of them have arrays or lists. Some of them just stores strings and integers. Our bank is going to have a list of accounts, and those accounts could be like, we don't want to specify. So for our bank, we're going to store a list of accounts, some of which are interest bearing, some of which are not, some of which are high interest bearing, other of which are not. So we have to be able to handle all of these different kinds of accounts. And so when we're talking about how we can store this data, we want to be generic to some extent. We want to have, sometimes we want to define a class that is going to just be able to hold anything. We don't want to prescribe, this is what this is going to look like. We want to say, whatever it is, I will take it. I just need to give it a name. And one possibility is to use object, because object is the implicit superclass of everything, right? So all of my classes, so my implicit superclass of shape is in fact object. So that's one option. And that was the option for a while until they introduced generics. And because what we're going to look at is this notion of angle brackets. And to answer the question of why bother, we want to use them when we don't know what kind of thing we're going to get. So if we have some box that's going to store something, and I don't know what kind of thing I'm going to get, then I'm going to make this class generic. So I'm going to open up Eclipse. I'm going to make a new class. And where do I want to put it? I'll put it in that package. And I'm going to give it a type parameter to say that my box is going to hold some type of thing. I don't know what type of thing is going to go in my box, but it's going to hold something. So it's like if I have my bag of markers, and if I'm like, before I put markers in it, when I just buy it at the store, it's empty, right? But some type of thing is going to go in there. I'm going to fill this bag with markers. But when they make it at the store, they don't know that I'm going to fill this bag with markers. They just know that I'm going to fill it with something. And so that's what this T says. So T, I guess, stands for type, where we're saying my box will hold something. And so that T is going to be a stand-in for our generic type. So whatever sort of thing lives in our box, we know what type it is. Well, we don't actually know, but we have a variable to stand in for that. To say the thing in my box will be of type T. And so I will say, I can declare my item, the thing that lives in my box. This is the name of the variable. T is the type. It, in fact, doesn't have to be just T. I could like give it whatever name I want. This is basically just a variable to say this is the type of thing that I will refer to, and then I can say any type 1, 2, 3. And that's the name of the type. But tradition says that we just keep it simple and just use one letter, and that letter is capital T. So refactor, rename T. Right? So it can be anything I want, but I'll just make it T. So I will generate my getters and setters. And now I've got a simple class that represents my box, where T, so this is the stand-in for this generic type. It's the return type when I get the item, because in Java, every variable we need to declare what kind of thing it is. What kind of thing is item? Well, it's type T, because I've said that my box will hold something of type T. And so when I get the item, I have to say, here's what kind of thing it is. When I set the item and get in the new version as a parameter, I have to say, here's what kind of thing that is. It's of type T. If I did not have these angle brackets here, then this would throw an error because it doesn't know what T means. So the angle brackets say, I am a container. Here's what kind of thing I will contain. So what does this mean? This is a generic type. So this allows for us to use any reference variable when we're using this item. And so any sort of reference type can go in those angle brackets when we actually create the object. So let's make a demo. Let's call it generics demo. Not that the name really matters. And so let's look at my options. What should we put? Does someone want to nominate a type that we've made that we should put in the box? That's okay. Let's put a person in the box. Yep. Say that again. Okay, so we're gonna have a variable person. So we should define a person first. What should our person's name be? We have Robert in the class? I don't think so. I'll name our person Bob. Okay. New person. And I believe, what is that? Name, it, height, and age. So our name is Bob. Our height is, we'll make Bob very tall and many years old. All right, so we have our person. Let's put the person in the box, where I'm going to have a box. That box will contain the type person. I'll call it lowercase b box. I haven't defined a constructor for the box, so it'll just initialize everything to null. That's okay. And then I can call box.setItem and give it Bob. So Bob is now in the box. We can put a person in there because we said the box is going to contain any kind of reference type. I don't know what it's going to be. And so we decided, okay, the reference type that's going to live there is a person. We could have chosen a square. We could have chosen a combo lock, right? We can put any sort of thing in our box. This angle bracket T lets us do that. And this actually holds still. So if we have capital I integer, if I import the things that I need to import, right, this should look familiar from when we're creating a list. The list has angle brackets too. This is how it's defined. It has in its implementation, if I hover over this, so if we go down and this says type parameters, angle bracket E, close angle bracket, the type of elements in this list. So it's just using a different letter than T. But it uses capital E to represent here's the type of thing that's going to live in this list. So we've been using this all this time. Now we just get to talk about what it actually is. All right. So any reference type can go between those angle brackets, even if we don't know what it is, even if we haven't created it yet. Once we create it, we can use it. When we are using a generic type, the class that is used with it is parameterized. So if we've got our class box T, when we have an object with a person inside of our box, now that object is parameterized. And so we've used list and array list. We've parameterized those already. So we've parameterized a list with an integer. And since any reference type goes in those angle brackets, that's why we need capital I integer, because capital I integer is a reference type and not a primitive. And so that's why we can't put ints in there, because it has to be a reference type. All right, so in terms of what can be made generic, we can make classes generic, where we put this angle bracket T after the class name. We can make interfaces generic. I've got a link here. This is from the Oracle documentation where they have made this comparable interface generic to allow for us to compare one type of object with another. I don't know what type of object you're going to be comparing, but it's going to be something. You can also make methods generic if you want to, both static and non-static. And so if you want to make a method generic, then you just put those angle brackets just before the return type. Okay. If you want more than one generic type, that's allowed. So for example, the Java map type. So this is another core data type that Java has defined for us. It's an interface, and this interface is parameterized with two generic types, K and V, which stand for key and value. And so this allows us to have, if we've got, nope, it took my drawing away. So this is like, if you remember a dictionary, we have some key and we have a value. So this is like, I want to know the meaning of a word. And so I look up that word in my dictionary and it gives me a sentence saying, here's what that word means. I have the key, which is the word that I want to know, and the value, which is its definition. And so these are some of the common names. So E for element, K for key, N for number, T for type, V for value, and so on. So the actual name of the generic type doesn't really matter, but these are some of the conventions. We can also restrict these generic types to be part of a specific hierarchy. So let's say we are writing some method that calculates the perimeter for a list of shapes, right? So if I have my list of shapes and I have a number, then I look at the first one and I ask, what's the total perimeter? And I add that number here. Then I look at the second and I ask, what's the total perimeter there? And I add that to my variable and so on. So I go through my list of shapes of that's a rectangle, that's a triangle, that's a circle, and so on. Find the perimeter, add it to my variable. I only want to be able to run a method like that on shapes. It doesn't make sense to ask a person, hey, what's your perimeter? Right? You don't know what that means. A person doesn't know what it means to be a perimeter. Only a shape knows that. And so for that reason, we want to use this ability to restrict, to say that we have a question mark, which says, I don't know what kind of thing I'm going to be given, but I say, but it has to be some kind of shape. And so whatever kind of thing I'm given, that's got to be a shape. So that allows us to restrict it, to say you have to be within this hierarchy in order to proceed. So in the lab, the mini lab, I'm calling this, I will give you, we've got a course class, we have a section class, some student classes, and we want to say that I want only students in, for example, my course roster. And so then I have to say for my course roster, it is some type where I only allow students in. So something extends student. Okay, so that's pretty much all I want to say for this. I have an activity for you. Did I put it on Canvas? I don't think I put it on Canvas. Let me do that. Okay, so one of the several ways to get this job done is to parameterize section to say that my section is going to hold some kind of thing, and that thing must be a kind of student. And so just saying T here and then saying student is insufficient because this allows me to do something like create a section of droids and then for O1 can be the name of my section. And so this allows me to do something like that. I can't then go and say droids dot enroll C3PO. That's going to give me an error because C3PO is not a student. But I was able to create a droid section, and I don't want that to have happen, right? It's like, it let me do this, why not let me do the rest of it? So that's why I don't want to just leave this as T. I could leave it as T and then say, when I go to parameterize my roster, I could put that extend student, except now it doesn't let me do that. I could do the question mark there. That might be a way around it. And then I could put some kind there. So there's like the errors kind of are trickling down. So the way to fix that and get around it is to say that T extends student. And then I can just say that my section roster will have some kind of student. And then I have to parameterize both my section roster when I declare it and in the constructor. I have to enroll that type. And down here, because this for loop goes through the section roster, and just change that to T as well. Because T is the type of thing that lives in my section roster. So if I do that, then this line has the error, which is what I want, because I don't want to be able to create a section of droids. And course tests. I'll show you what it looks like on VS Code. So that gives me a check mark. So this passes the test. And so as I was walking around, even if the test cases pass, that doesn't always mean that you're completely done, because of this question of like, it technically passes, but I'm able to create a droid section when that's not what I want. So that's my little genericity activity. Hooray, you did it. I have other things of, if using generic types, you put it after the class name. I'll skip past this. We talked about this, how primitive types can't be used as a type parameter. It's going to give you an error. And so instead you need to use the wrapper classes, which is like the capital I, the capital D for double, capital B for Boolean. And if you want to use generic types, but some things are static, that's where things get dicey because of something that happens during the compilation process where it erases the there's something called type erasure that happens during compilation. And if you're working with something static, then it doesn't know how to access that. Once we have generic types, we cannot instantiate them. We can declare them. We can't instantiate them because I don't know what T is, right? I don't know what that class looks like. That's just like a stand-in. It's my cardboard cutout for some type. And similarly, we can't create an array of that generic type. All right. So now we've got some time to talk about what we've learned so far. So we've talked about how do we make a class. So we talked about what's an object, what's a field, what's a method, a member, what's a constructor, why can we have more than one? What does it look like to have more than one? Should fields be public or private? What are setters and getters? So this is our blast from the past. We talked about important syntax. So like toString prints information about an object. We define what toString looks like. Talked about equals. We talked about this, how we refer to our current object. We talked about main. What's that method signature? Do we have it in a class or not? Talked about static, where static means that we do not require a controlling object. We talked about packages, which are just folders that our code lives in. We talked about different visibilities that things can have. So public means anyone can see it. Private means no one outside of our class can see it. Package visible means anyone inside our folder can see it. And protected is package visible plus any of our subclasses can see it. We talked about inheritance of extending classes, where if we have a person, student, and employee, we can say that, let me bring up the drawing again. So we can say that a person is a student and a person or an employee is also a person. We talked about what things get inherited, what things get overridden. How can we override things? So like for whenever we define toString, we are overriding the original toString that lives in object. When we want to have a method that's not going to be implemented, but we want it to be inherited so that other people can implement it. This is like Lab 5 with employee. We have a class with an abstract method, and that means that the class itself is abstract. And so then the subclasses have to implement that method themselves. We talked about interfaces. Interfaces are method contracts. And if we want, it kind of gets us around that multiple inheritance question. Interfaces is pop quiz, and is an interface a class? No, it's not. This might come up on your exam. An interface is a method contract. It's saying implement these methods, and then you have to do that. So those are public and abstract, and you use it with implements. And then we talked about generic types, where we define those with these angle brackets that go after the class names. We can restrict it to somewhere in the hierarchy. And with that, we've done the basics of object-oriented programming. Hooray. So we went through all of this, and it's all super complicated, but we're going to use this going forward after the exam. So the exam serves as sort of our checkpoint of, do we understand what's going on? Do we understand why we use objects? Of what are the different settings that we can have for objects? That's basically what we're talking about, because we will create objects and talk about them in terms of the crucial data structures that you need to know. Okay. So we've got about 22 minutes. So now I want to talk about the exam. Let's split my display again. All right, I'm going to pause recording for talking about the exam.